Think you know Mercury? Think again. This is a planet where temperatures swing by over 1,000 degrees in a single day, where the sun appears to rise, set, and rise again, all in one morning. Welcome to Mercury, the most extreme, mysterious, and underestimated planet in the solar system. Let's unlock its secrets. Mercury is often overlooked. It's small, it's hard to see from Earth, and it doesn't have the colorful clouds of Jupiter or the rings of Saturn. But Mercury deserves attention. This is the planet that defies expectations. It's the closest to the Sun, yet it still harbors water ice. It's ancient, but it's still active, shrinking as its core cools. And it moves at incredible speeds, racing around the Sun in just 88 days. But that's just the beginning. In this video, we'll take an in-depth look at everything that makes Mercury extraordinary, from its extreme environment to the mysteries scientists are still working to solve. If you're ready to see Mercury like never before, let's dive in. Mercury holds the title of the fastest planet in the solar system. It zips around the Sun at an average speed of 29 miles per second, nearly 112,000 miles per hour. That's so fast that ancient astronomers named it after the Roman god Mercury, the fleet-footed messenger. But Mercury's orbit is far from ordinary. First, it's the most elliptical orbit of all the planets, which means its distance from the Sun varies dramatically. At its closest approach, or perihelion, Mercury is just 29 million miles from the Sun, while at its farthest, or aphelion, it's about 43 million miles away. This elliptical orbit is part of what causes Mercury's extreme temperatures. And then there's Mercury's resonance. The planet spins exactly 3 times for every 2 orbits it completes. This 3:2 spin-orbit resonance means a single solar day on Mercury, sunrise to sunrise, lasts 176 Earth days. Imagine waking up to a sunrise that took half a year to return. Mercury's unique characteristics likely stem from its violent formation. Most scientists believe Mercury started as a much larger planet. Early in the solar system's history, a massive impact, similar to the one that created Earth's moon, may have stripped away much of Mercury's outer layers. This would explain why Mercury's core is so large compared to its size. The core, primarily made of iron and nickel, accounts for about 85% of the planet's diameter. To put that into perspective, Earth's core is only about 55% of its diameter. This makes Mercury the densest planet in the solar system after Earth, with a density of 5.43 grams per cubic centimeter. Surrounding this massive core is a thin silicate mantle and crust, just 300 to 400 miles thick, about as thin as the skin on an apple compared to its overall size. This unusual structure raises intriguing questions. Why did Mercury end up like this, and what can it tell us about the solar system's chaotic early days? Mercury's magnetic field is another puzzle. It's much weaker than Earth's, about 100 times weaker, but its very existence is surprising. Why? Because magnetic fields are generated by molten, flowing metal in a planet's core. Scientists once thought Mercury's core would have cooled and solidified long ago, given its small size. Yet, messenger data showed that Mercury's core is at least partially molten. This discovery led to the theory that sulfur, which lowers the melting point of iron, might be present in the core. The result? A weaker but persistent magnetic dynamo. Mercury's magnetic field isn't just an academic curiosity, it interacts with the Sun's solar wind to create magnetic tornadoes. These funnel charged particles to the surface, constantly reshaping the planet's thin exosphere and etching patterns into its surface. Mercury's surface tells a story of violence and survival. Its battered, cratered landscape resembles the Moon, but it's far more dynamic than you might expect. Take the Caloris Basin, for example. This massive impact crater is about 960 miles across, large enough to cover Alaska, and surrounded by concentric rings of mountains over a mile high. When the asteroid struck, it created shockwaves that traveled through the planet, causing weird terrain on the opposite side where the ground buckled and cracked. Beyond craters, Mercury's surface is marked by lobate scarps, massive cliffs created as the planet shrinks. These cliffs can stretch for hundreds of miles and rise over a mile high. Imagine a world that's essentially wrinkling as it cools down. Messenger also revealed evidence of volcanic activity. Smooth plains of cooled lava cover much of Mercury, suggesting that ancient eruptions helped shape the planet's surface billions of years ago. No planet experiences temperature swings as dramatic as Mercury. During the day, the sun-facing side can reach blistering highs of 800 degrees Fahrenheit 430 degrees Celsius. But at night, without an atmosphere to retain heat, temperatures plunge to minus 330 degrees Fahrenheit minus 200 degrees Celsius. Despite these extremes, Mercury isn't completely barren. Water ice exists in permanently shadowed craters near its poles, where temperatures never rise above freezing. This was one of Messenger's most exciting discoveries, as it suggests that even the most inhospitable worlds can harbor key building blocks of life. Mercury's exosphere is equally fascinating. Unlike an atmosphere, which is stable and dense, Mercury's exosphere is a tenuous cloud of atoms, constantly replenished by solar wind and impacts. Sodium, calcium, and magnesium are among its components, creating a faint, ghostly halo around the planet. Mercury has always been a tough target for exploration. Its proximity to the Sun means spacecraft need to fight both intense heat and strong gravitational forces. Despite these challenges, humanity has made impressive strides. The Mariner 10 mission in the 1970s was the first to visit Mercury, capturing images of about 45% of the planet. Decades later, NASA's Messenger mission revolutionized our understanding. From 2011 to 2015, Messenger mapped Mercury's surface, analyzed its composition, and measured its magnetic field. The next chapter in Mercury exploration is the European-Japanese Bepi-Colombo mission, currently en route to the planet. Once it arrives in 2025, it will deploy 2 orbiters to study Mercury in unprecedented detail, from its magnetosphere to its geology. Mercury may be small, but it's a planet of superlatives, the fastest, the densest, and one of the most extreme. From its oversized core to its volatile surface, every aspect of Mercury challenges our understanding of the solar system. If you've enjoyed this deep dive, make sure to like, comment, and subscribe for more incredible explorations of the cosmos. Which planet should we cover next? Let me know below. And until next time, keep looking up.